Hello students, welcome to Physical Science Digital Classes MAHABUBABAD. 10th class Chemical Equations Part 3. Today in this session we are going to discuss about making chemical equations more informative. Myself Narendra Babu Kotla, PGT Chemistry, TSMS, MAHABUBABAD. So making chemical equations more informative. If you take any one of the chemical equation, so how we can make that equation as more informative? Then what is more informative? So the equation which gives more information about chemical reaction is known as more informative. That means if you take any one of the equation, if it gives more information in the sense not only about the reactants and products and their symbols and their formulas. Not only this, it should give some more information. Then only the equation becomes more informative. So chemical equations can be made more informative by expressing following characteristics of the reactants and products. So some of the characteristics we have to follow, and by following those characteristics we can make chemical equations more informative. And let us see what are those characteristics. The first one is physical state. By expressing the physical state, by showing the physical state of reactants and products, we can make the equations more informative. And the second one is heat changes, exothermic or endothermic. And third one is gas evolved, if any. So fourth one, precipitate formed, if any. So by using these four characteristics, so we can make the chemical reaction more informative. And first one is expressing physical state. By expressing the physical state, in the sense actually, so there are three types of the physical states are there. Physical state of a substance mentioned along with their chemical formula. Physical state of substance mentioned along with their chemical formulae. So that means we have to mention the physical state of that substance along with that chemical formula. What is the formula present? So along with that we have to mention the physical state or phase of that compound. So there are different types of the states are there, and those states are generally, gaseous state is the first one. And if you observe, if any one of the reactant or product, if it is in gaseous state, then we have to represent it with G. Not only the Z, along with that brackets we have to represent. Okay, if any one of the reactant or product or the substance, if it is in gaseous state, then we have to represent it with Z. If the substance is liquid state, that means reactant or product, any one of the substance, if it is liquid state, then we have to represent it with L. We have to represent it with L. And the next one is a solid state. If any one of the substance, if it is a solid state, if it is in solid state, then we have to represent the letter, so that is S. S indicates the solid. And coming to the next, aqueous. Aqueous. So aqueous means any one of the substance which is soluble in water. That means if you take any one of the substance, if it is soluble in water, then that we have to represent as aqueous, AQ. Like that we have to represent aqueous in the sense. Understood? So aqueous in the sense we have to represent AQ. What is aqueous? For example, if you take the sodium chloride. Sodium chloride, if you add it to the water, then you are taking the solution of the sodium chloride. That's why sodium chloride aqueous, AQ we have to represent. And coming to here, showing phases in chemical equations. So let us take the example here, H2O. H2O, S. S in the sense, as per our previous discussion, solid. S in the sense, solid. Okay. So actually H2O solid in the sense that is ice. Ice in the sense the formula H2O, we are representing it with the solid. So this red mark that indicates, that means this delta indicates the heating actually. So if you heat this H2O, which is a solid, means ice. If you heat this ice, this H2O converts into the liquid. Okay, liquid. That means H2O, we are representing it is in liquid state now. Again, if you heat this liquid in the sense water, again if you heat this water, so then it gives the vapor. That means H2O in gaseous state. So these are the solid state, liquid state and gaseous state. Like this we can represent the phases. So let us go through the once again the phases. So solid phase. Solid phase in the sense the substance is relatively rigid and has a definite volume and shape. So that is the solid state. Substance is relatively rigid and has a definite volume and shape, then we can consider it as a solid phase. For example, sodium chloride. Sodium chloride salt, that is solid, we can represent like this. And the next one is liquid phase. The substance has a definite volume but it is able to change shape by flowing. If any one of the substance, it is having the definite volume, but it can able to change its shape by flowing, by moving. Okay, example H2O, which is in liquid state. Okay, and coming to the gaseous phase. So the substance has no definite volume, no shape, and it shows a little response to gravity. That is generally gaseous phase. Example Cl2, chlorine gas, we are representing as Z. Coming to the aqueous state. If the substance is present as a solution in water, that is aqueous state. That means if the substance is present in the sense, here we have to consider if the substance is dissolved, so in a solution, that is or dissolved, so in water is generally called as aqueous state. If any one of the substance that is dissolved in water, then that solution is called as aqueous solution or aqueous state. For example, NaOH, sodium hydroxide. If you add it to the water, the solution of sodium hydroxide, that is aqueous state, that is in aqueous state. Okay, and coming to the next, let us take the examples to represent the these states of these states. So the balance equation along with the physical states as, for example, iron oxide, which is called as ferric oxide. Actually, it is in solid state. Ferric oxide is in solid state. So plus aluminium. Aluminium is also solid state. If you heat these two, these are the two reactants. Iron oxide and aluminium are, so we are taking them as solid state, and these are the reactants. So these reactants on heating, then it gives the iron, which is a solid state. And aluminium trioxide, this is also solid state. That means this equation, so that is not only giving the formulae, not only giving the the conversion of the reactants into the products, it is also giving the information. So more information the given are the substances which are taken in this, the substances, whether they are solid state or liquid state or gaseous state, we are clearly giving information. So that means this equation is more informative. Let us take the one more example. Zinc sulfide, which is taking as a solid, S in the sense a solid. H2SO4 aqueous, aqueous in the sense this H2SO4 has taken in water. So if you make them react together, then it forms the zinc sulfate, which is aqueous, means dissolved in water. Along with this, it releases the H2. H2 in the sense it is in gaseous state, it liberates the gas. This is about the physical states. So let us take the one more. That is expressing the heat changes. Heat changes in the sense, if you take any one of the reaction, either heat may absorbs in the reaction, either that heat may releases in the reaction. Based on that, we can classify these reactions into two types. So in that, the first one is exothermic reaction. Exothermic, the name exo itself indicates here, the name exothermic in the sense exo, we have to remember as exit. Exit in the sense going out, that means releasing out. Thermic, heat energy, that means what is exothermic in the sense the reaction that release heat energy through the surroundings is called exothermic reaction. That means if it releases the heat energy, then it is called as exothermic reaction. Coming to the example here, carbon on reaction with oxygen, okay, or carbon on combustion with oxygen, then it gives the carbon dioxide. Along with this, it releases the heat energy. This plus indicates the releasing. So if you represent the plus heat towards the product's side, then it is exothermic reaction. Remember this, important for the half mark, 1 mark bits. And coming to the calcium oxide. So this calcium oxide reacts with the H2O, means or that dissolves in H2O, then it forms the calcium hydroxide. Calcium hydroxide, CaOH twice. Along with this, it releases the heat energy. Okay, so products side we are representing the plus heat, or instead of the heat we can also represent the capital Q. If you can represent the capital Q also, it's not at all problem to us. Okay, so we can represent it with capital Q also. Okay, capital Q. Right, we can also represent it with the capital Q. If you represent plus Q indicates the exothermic reaction. Okay, plus Q indicates the exothermic reaction. Here also the heat liberates, and heat plus heat, if you represent, that is the exothermic reaction. Okay, instead of the heat you can also represent the Q. Okay, right. And next one is endothermic reaction. So endo means the name itself indicates into, means into, inside. Thermic means so takes. Okay, the reaction in which the heat energy is absorbed into the reaction are known as endothermic reaction. The reaction in which heat energy is absorbed into the reaction is known as endothermic reaction. It absorbs into the reaction, it takes into the reaction. Okay, so in this sodium bicarbonate 2NaHCO3. NaHCO3 is a sodium bicarbonate. So it takes the heat energy, okay, and it gives the sodium carbonate, carbon dioxide and water. It releases these 3 compounds. In this heat we are representing towards the reactant side. If you represent the heat towards the reactant side as a plus sign, then that indicates the endothermic reaction. If the same thing, we can also represent this heat beside this H2O, but we have to represent it as minus. Okay, minus in the sense it is absorbing in this. So let us take one more example. Calcium carbonate on heating, calcium carbonate CaCO3 on heating, it gives the calcium oxide plus CO2. This is endothermic reaction. Okay, endothermic reaction. Endothermic in the sense heat we have to represent towards the reactant side as a plus sign, otherwise as a minus sign towards the products. This is about the endothermic exothermic reaction and heat changes. Okay, heat changes we can also represent with the capital Q also. And coming to the next one, expressing the gas evolved. So in this, if gas evolved in a reaction, it is denoted by an upward arrow. This is the upward arrow. If any one of the gas released or evolved in a reaction, it is denoted by upward arrow. So that means actually, this upward arrow reaction symbol that will be represented towards the product side only. Why? Because during a reaction, in the sense reactants when they are reacting, then there is no possibility to represent the gas evolution towards the reactant side. Only reactants, while they are converting into the products, there is a possibility of releasing the gas. That's why this symbol always we have to represent, if possible, if it is necessary, then towards the products side only. Okay. Otherwise, if you want to represent the gas, then we can represent the G. So if the substance, you are going to mention this. So next example, zinc, which is on treatment with the sulfuric acid, that gives the zinc sulfate and H2 gas that releases. Actually H2 which is in gaseous state, and this indicates that gas is evolving here. Okay. And the fourth one is last one, expressing precipitate formed. What is precipitate? If any one of the substance which is formed during a chemical reaction, if it is insoluble in that solution, that is called as precipitate. If any one of the substance which is formed during a chemical reaction, if it is insoluble in that substance or in that solution, that is called precipitate. So what is precipitate in the sense, if a precipitate is formed in reaction, it is denoted by a downward arrow mark. Okay, this downward arrow mark is also you have to represent towards the product's side. There is no possibility to represent towards the reactant side. Keep this in your mind. Coming to the example, AgNO3, silver nitrate. So we are taking in aqueous form. Aqueous in the sense which is soluble in water. Okay, sodium chloride also taking in aqueous form in water. So if you react these AgCl and NaCl together, then it forms the silver chloride AgCl, which is a solid, which is insoluble in that solution. That's why you can represent it with downward arrow symbol. Okay, and another one is a sodium nitrate, which is in aqueous state. So finally here the substance, this indicates the which is insoluble, that is the precipitate formation we can represent with the downward arrow. And coming to the next, other than these four expressions, some reaction conditions such as temperature, pressure, catalyst, etc. so are also indicated above and are below the arrow in the equation. Other than the temperature, other than these four above so characteristics, sometimes we have to represent the temperature conditions and pressure conditions and catalyst also. What is the catalyst we are using in that reaction? So we should represent all these sometimes. So while representing, where we have to represent all these temperature, pressure, catalyst in the sense above or below the arrow in the equation. Let us see the example here. 2AgCl, silver chloride, which is a solid. So this is so actually on treatment with the sunlight, on reaction with the sunlight, so it splits into. So that means here in presence of this sunlight, this AgCl is converting into the silver solid and chlorine. Actually here this is not a balanced one, the equation. So here 2Ag, here we have to represent here. So that is 2Ag we have to represent there. Understand? Let me show this. 2Ag. Here so 2Ag we have to represent, of course, but chlorine Cl2 we have to represent. And coming to the next one is 6CO2, which is taken in gaseous state, and 6H2O. So CO2 is reacting with the H2O in presence of the sunlight and chlorophyll, in presence of the sunlight and chlorophyll, and it forms the C6H12O6, so which is glucose. Along with this, so it releases the oxygen, which is in gaseous state. So like that, the conditions also we can represent, so above or below the arrow, like the sunlight and chlorophyll, like this we can represent here. Okay, right. Coming to the next, so some additional symbols used in chemical equations. Actually, what are the symbols? Till now we discussed only. Finally, I am giving some information here again. And coming to here in this is the arrow mark. So this arrow mark, so we should place this arrow mark between the reactants and products. And this arrow mark, the head of the arrow mark, this indicates the direction of the reaction generally. Okay. So this is arrow mark is yields, indicates the result of a reaction. And the direction of a reaction it indicates. Double-headed arrow mark. So this indicates the reversible reaction. That means reactants are converting into products as usually at the same time. So products are also converting into the reactants. This indicates like this. And the next one, solid, S. So where we will use this solid means a reactant or product. If it is in a solid state, then we can represent this ES, solid state. So down-headed arrow mark or downward arrow mark. This indicates the precipitate in the sense which is insoluble in a solution. If a substance is insoluble in a solution, then we can represent it with the precipitate. L, liquid state. So a reactant or product, if it is in liquid state, then we can represent it with the L. Aqueous. So that means a reactant or product in an aqueous solution means dissolved in water. If you take any one of the reactant, or the produced product, if it is in water which is in dissolved state, then we can represent it with aqueous. Okay, so G means gaseous. So a reactant or product in the gaseous state, then we have to represent it with the G, gas. It indicates the gas. And the next one, so this is the upward arrow. Upward arrow that indicates alternative to the gas, G indication. But this is used only to indicate the gaseous products. So we cannot able to represent this in reactants. Only we can represent the gaseous products for this. Next one is, so just now we discussed arrow. So above the arrow we are representing the delta. So this indicates the, so reactants are heated. Whatever the reactants we have taken, so towards the left hand side, and those reactants we are just making them heat. Okay, right. So here it indicating the pressure. For example, above the, so arrow mark, we are representing 2 atmospheres. So that means the reaction is generally taking place at 2 atmospheres pressure. The pressure at which reaction is carried out, so in this case especially 2 atmosphere. Instead of the 2 atmosphere, if the reaction takes place at 5, then we can represent 5. If takes place at 1 atmosphere pressure, then we can represent at 1 atmosphere pressure. So simply we can represent this pressure in the sense, pressure at which reaction is carried out exceeds normal atmospheric pressure. So when we are representing this pressure P, pressure at which reaction is carried out exceeds normal atmospheric pressure, then we have to use this symbol. And coming to the, so this is the representation of the temperature, 0 degrees centigrade or 10 degrees centigrade, 20 degrees centigrade. So that means at which temperature the reactants are going to react, that indicates. That means the temperature at which reaction is carried out in this case, that is 0 degrees centigrade. And coming to the MnO2, so upon the arrow mark we are representing. That means representation of the catalyst. If any one of the reaction that takes place in presence of a catalyst, so that catalyst we have to represent above this, so arrow mark. Here in this case, MnO2, manganese dioxide, is the catalyst. Instead of that, we can also represent so many catalysts. Platinum as a catalyst, palladium as a catalyst. Okay, so here it indicates the formula of catalyst. This indicates the formula of catalyst. In this case, manganese 4 oxide used to alter the ratio of the reaction. Thank you for watching this video.